Hey guys, so in this video we will introduce how to visualize and summarize data using a tool called R. This lecture is actually going to come at you in 3 parts, so feel free to take a break at any point. Let's go ahead and jump in. So in this section we're going to talk about how to summarize data. Let me get that search bar out of the way for you. With one sort of guiding principle. If I'm not going to do something as a professional statistician, I'm not going to expect you guys to in this class. I want this to really mimic the statistician's experience as much as it can. So what that means is I don't look things up in tables. I do very little calculations by hand. You will do a few calculations in this class. But for the most part, I use computational tools. I use software. One software tool that I use very frequently is something called R. So let's talk about R. What is it? What you're looking at right now is actually a screenshot of the RStudio window. So let me back up just a little bit. R is a statistical programming language. Yes, you heard programming language. So we are going to be writing code in this class. For the most part, the code itself is very straightforward. R was written to do statistics, so it understands data very, very well. The program or the environment that we're going to use to interact with R is something called RStudio. Now, RStudio provides a really great way or a great interface for interacting with data, viewing the results of your analyses, and then saving your analyses for later use. We can use RStudio in 2 different ways. There's the RStudio version that you can download on your own computers. Both R and RStudio are completely free for you to use at home, which, to be perfectly honest, is a major selling point that these are free. There is another product available to you guys called RStudio Cloud, which is a web-based browser version of RStudio. So because that was a lot of R's, let's go back through this. R is the programming language. So when we are writing code, it will be R code. We'll write R code within RStudio, which is that interface for working with R. Sometimes you may prefer to use the cloud-based version. That is RStudio Cloud. Okay, so if you've never learned a programming language before, you may be a little bit shook. That's okay. It's a learning curve to learn to program. Here's how you get through it. You breathe. You go into it knowing that you're going to make mistakes. Even now, I make mistakes all the time, and I've been programming in R for 10 years. You ask for help. I am always available, always willing to help you with your R code. Send me an example of the code you're using. Let me know what data you've got. I will do my best to try to troubleshoot it. One strategy that I like to use is translating code to plain English to code. Think about the steps that you want to accomplish before writing the code that goes with this step. Finally, don't reinvent the wheel. Throughout the slides, the activities, the homework assignments, you will see sample code. This is on purpose. Copy, paste, change. Feel free to use the code that you're provided with. Okay, so let's go ahead and jump into an example with a data set. So the data set that we'll be using in this set of lecture videos is the ICU admissions data set. This includes information on 200 patients admitted to the intensive care unit at a hospital. 16 of these variables are given for the patients that are being admitted. The code that I'm using here, this function head, let me highlight it for you, will show you the first few observations of the ICU admissions data set. So the variables that we have in this data set, we have an ID number for each patient. We have their status, so the vital status when they left ICU care, either alive or dead. We have the patient's age and year. We have their sex. We have their race. We have service and ICU admission. Did they come in from the emergency service of the hospital or the elective? Service is medical or surgery. Apologies for that confusion. whether or not they were admitted because of cancer, whether they have a history of chronic renal or kidney failure, infection at ICU admission, whether or not they had received CPR, systolic blood pressure, heart rate, previous admission to an ICU unit, type of admission, fracture, and then finally, level of consciousness. So that's the data we have for these patients. Let's talk a little bit about how R thinks before we start to see some examples. R is what's known as a functional programming language. So if you've ever used, for example, Excel formulas before, they're kind of like that. We have functions on the outside of parentheses, and then within those parentheses, we'll tell R the data set to use, the variables to use, and then the various options that we can select for a particular function. So if you've used Python or Java before, this is going to feel different. R was initially designed, again, for statistics, graphics, working with data, so it's a very data native language. One other thing that you'll see throughout the semester are what are called libraries. So in R, we have a set of what are called base functions. These come automatically, but we can add in extra libraries. Think of these like apps for your phone that let you do more things, let you access more functions or more options. That's what these libraries do. We're going to use 3 libraries throughout the semester. We're going to use a library called the Tidyverse to help us plot data and to help us manipulate data sets. We'll use the OI Biostat library. That is the library that comes with our textbook or is suggested for our textbook. Primarily, we'll get data sets from that library. And then finally, we'll use a library called the Mosaic library, which contains some functions for calculating summary statistics, working with models and tests. We will talk about how to install these 3 libraries in class. They're all fairly straightforward to install. If you're working with RStudio Cloud, I will install them for you. So that's an advantage. For the cloud-based version, they'll be there ready to go. Okay, so the first function that we'll learn in R is actually a base R function. This is called the summary function. For numerical variables, what this summary function does is calculate various summary statistics. Take a look at age. Some of these are going to look familiar. For example, the median age in this data set is 63 years old. The mean is 57, the minimum is 16, the max is 92. These other 2 statistics are called the quartiles. We'll talk about these a little bit later on. When R senses that there's a numerical variable, the summary function calculates these by default. For categorical variables, we don't get much information. We get the length of the variable. That's just how many observations there are. So if we want to summarize categorical variables, this summary function isn't going to help us out very much. Moreover, the output of this summary function is quite frankly gross. We can do a little better. So let's say we'd like to know how many patients in this data set were emergency ICU admissions. Well, the type is elective versus emergency, so whether or not they came in with a planned elective procedure or an emergency procedure. Here's what we'll do. We'll start with our data set. This is the ICU admissions data set. We'll use this kind of funny symbol, this %. This is known as a pipe symbol to send this into the group by function. So that group by function is going to take the ICU admissions data set, group it by type. We'll then summarize it with a variable called n, or we'll create a variable called n, which is just counting up each of the observations. So we now know that 53 patients came into the ICU following an elective procedure. 147 came in following an emergency procedure. Okay, so let's talk about this pipe thing. So this pipe operator is something that's common in a lot of programming languages. What this does is take everything on the left-hand side and sends it through to the right-hand side. So it's a way to make iterative changes to your data set without having to save in between. So this pipe operator has a really nice illustration on Twitter, which unfortunately is not showing up in my slide deck, boo, but I will link it online for you to see. Essentially, think of this as just passing everything through. Everything's going through step by step. Okay, so let's go back to our code. So in words, what are we doing? Well, we're starting with the ICU admissions data set. We're grouping it by type. We're then summarizing the number of observations. So try to think of our examples in plain English. Let's say we'd like to, for example, calculate the proportion of patients in this data set that had been admitted to the emergency room. That's the kind of calculation that we'll do by hand in this class. We can also use R, of course, like a calculator. So about 73.5% of patients had been admitted to the emergency room. This is something that we'll refer to as the sample proportion. So the proportion of people or subjects in our sample that satisfies some characteristic. In class, we will denote this as p hat. So our p hat is our sample proportion. So if we'd like to know, for example, how many patients in our data were 50 years old or less, here's how we would do it. We would take this ICU admissions data set. We would then filter out all of the subjects who are age 50 or less, so less than or equal to 50. There are 62 of those, so our sample proportion is 62 out of 200. Now is a good time to take a quick timeout. So I'm going to go ahead and stop the recording here. In the next video, we will go ahead and continue and start talking about how to visualize data. See you in a few.